Imagine living on a planet where the sun never rises. Not because it's hidden behind clouds, not because of an endless storm, but because one side of the planet has been facing its star for millions of years without ever turning away. It sounds impossible, yet NASA has discovered worlds where this is exactly what happens. On one side, daylight never ends. Temperatures soar beyond anything humans could survive. On the other side, eternal darkness stretches across frozen landscapes that have never seen a sunrise, not once in their entire existence. How can a planet stop experiencing day and night? And if one half is burning while the other remains frozen, could anything possibly survive between them? By the end of this documentary, you'll understand the remarkable physics behind these extraordinary worlds and why they're changing the way scientists search for life beyond Earth. The story begins about 41 light-years from Earth in the constellation Pisces. There, astronomers studying a faint red dwarf star found an unusual planet called LHS 3844b. At first glance, it didn't seem especially unique. It was slightly larger than Earth and orbited incredibly close to its tiny star. But then, scientists calculated something astonishing. The planet completes an entire orbit in just 11 hours. That's less than half a day on Earth. Being so close to its star means gravity behaves differently than what we're used to. Over millions of years, the star's gravitational pull slowed the planet's rotation until something extraordinary happened. The planet became tidally locked. Just as our moon always shows the same face to Earth, LHS 3844b always shows the same face to its star. One hemisphere remains trapped in permanent daylight. The opposite hemisphere never sees the star at all. There is no sunrise, there is no sunset, only endless day and endless night. For decades, scientists suspected planets like this existed, but only in recent years have telescopes become powerful enough to study them in detail. NASA's Transiting Exoplanet Survey satellite, better known as TESS, first detected LHS 3844b as it crossed in front of its star. Each tiny dip in starlight revealed clues about the planet's size and orbit. Then came an even bigger challenge. Could astronomers determine what conditions were actually like on its surface? Using observations from powerful infrared telescopes, researchers measured how heat was distributed across the planet. The results were startling. The day side appeared blisteringly hot. The night side appeared dramatically colder. Normally, an atmosphere helps spread heat around a planet through powerful winds. Earth's atmosphere constantly moves warm air from the equator toward colder regions. But LHS 3844b seemed different. The enormous temperature difference suggested almost no atmosphere at all. If true, the surface is directly exposed to the harsh radiation of its nearby star. Without clouds, without weather, without oceans, just bare rock enduring endless daylight on one side and endless darkness on the other. It was one of the clearest pieces of evidence that some rocky planets can lose their atmospheres entirely. But this discovery raised an even deeper mystery. If tidal locking creates such extreme environments, does it automatically make a planet uninhabitable? For years, many scientists thought so. After all, one side seems far too hot, the other appears unimaginably cold. Yet nature often refuses to follow our expectations. As astronomers discovered more tidally locked planets around small red dwarf stars, they realized something surprising. Not every permanently lit world is as lifeless as LHS 3844b. Some may have thick atmospheres capable of transporting heat around the planet. Others may even possess vast oceans. And between eternal day and eternal night lies a narrow region scientists call the terminator zone, the boundary where sunlight and darkness meet forever. Unlike Earth, where sunrise constantly moves across the globe, this boundary never changes position. On some worlds, researchers believe temperatures there could remain relatively stable for billions of years. Could that thin ring between fire and ice become one of the most promising places in the galaxy to search for life? To answer that question, scientists had to look beyond one extraordinary planet toward an entirely different system where eternal daylight might actually create the perfect conditions for habitability. That discovery would transform the way astronomers think about worlds with no sunrise.
The search led astronomers to one of the most famous planetary systems ever discovered, TRAPPIST-1. Located about 40 light-years from Earth, this tiny red dwarf star is surrounded by 7 rocky planets. Because they orbit so close to their faint star, scientists believe that most, if not all, are also tidally locked. That means, on several of these worlds, the sun may never rise. Instead, one side could experience eternal daylight, while the other remains in permanent darkness. At first, this sounded like terrible news for the possibility of life. But computer simulations began telling a very different story. Researchers found that if a tidally locked planet has a sufficiently thick atmosphere, powerful global winds can carry heat from the scorching day side to the frozen night side. Instead of one side becoming unbearably hot and the other impossibly cold, temperatures could become much more balanced. Even more intriguing, if liquid water exists, enormous weather systems could continuously move moisture around the planet. Clouds might gather over the permanently sunlit hemisphere, reflecting some of the incoming starlight back into space and preventing runaway heating. Meanwhile, warmth transported across the planet could stop the night side from freezing completely. In other words, tidal locking does not automatically make a planet uninhabitable. In some cases, it may simply create a completely different kind of climate than anything found in our solar system. This realization dramatically changed how scientists evaluate exoplanets around red dwarf stars. Since red dwarfs are the most common stars in our Milky Way, many potentially Earth-sized planets are expected to orbit close enough to become tidally locked. If these worlds can still support stable climates, the number of potentially habitable planets in our galaxy could be far greater than previously imagined. But proving this is incredibly difficult. Even our most advanced telescopes cannot yet capture detailed photographs of these distant surfaces. Instead, astronomers study tiny changes in light. As a planet orbits its star, different regions rotate into view from our perspective. Sensitive instruments measure subtle variations in infrared radiation, allowing scientists to estimate temperature differences across the planet. This technique has already revealed valuable information about worlds like LHS 3844b and continues to improve with newer observatories. Today, the James Webb Telescope is giving researchers an unprecedented opportunity to analyze the atmospheres of rocky exoplanets. By examining starlight that passes through or reflects from a planet's atmosphere, Webb can identify gases such as water vapor, carbon dioxide, and methane under the right conditions. Each observation helps answer one enormous question. Can planets with no sunrise still support environments where life might exist? Scientists remain cautious. Many red dwarf stars produce powerful stellar flares that can blast nearby planets with intense radiation. Over billions of years, that radiation may strip away atmospheres, just as researchers suspect happened on LHS 3844b. Without an atmosphere, there is little protection from extreme temperatures or harmful radiation. Yet, not every star behaves the same way. Some red dwarfs are quieter. Some planets may possess stronger magnetic fields. Others may have thicker atmospheres that survive despite constant stellar activity. Every new observation adds another piece to this cosmic puzzle. Perhaps the most fascinating lesson is that our intuition often fails beyond the solar system. For generations, we assumed that planets needed familiar day and night cycles to resemble Earth. Now we know nature is far more creative. A planet without sunrise is not a broken world. It is a world shaped by gravity, orbital mechanics, and millions of years of cosmic evolution. Some become barren landscapes of exposed rock. Others may hide stable climates along a permanent twilight band. And somewhere among the billions of stars in our galaxy, there may be a world where life has never experienced dawn. Not because the sun disappeared, but because it has always remained fixed in the same place in the sky. The next generation of telescopes may not only reveal what these extraordinary planets are made of, they may finally tell us whether life can flourish under an eternal sky. Because sometimes the strangest worlds are not the least likely to matter. They are the ones that redefine what we thought was possible.